Hello everyone, this is Design Group ECE.24 from the Department of Electrical and Computer Engineering at USC. First, let me introduce our senior design topic. The title is Communication Aid for the Elderly. And here are our presentation contents. So, how did we come up with this idea? We all know that more and more people communicate with each other by using smartphones and computers. However, there are still many elderly people who have difficulty operating a computer or smartphone. We felt that what these elderly people need is an easy-to-use communication device. With this in mind, we developed a text messaging device based on a wireless connection to the internet using an inexpensive Raspberry Pi microcomputer. The unit also has a wirelessly connected panic button that may be worn as a neckline for the user to press in an emergency. This causes a text message alert to be sent to a pre-stored number. My partner Zheng Yiming will show you how it works at the end of this video. So now, let's mention some technical details. We use the Raspberry Pi Wi-Fi module to connect to the internet and access to a service to send and receive text messages. We use a nifty tool called ngrok to open a tunnel to our local machine. ngrok generates a custom URL that we use to tell Twilio where to find our application. And accessing to the internet also allows us to interface with Google for speech-to-text capability.
Okay, we now go to the part 3, speech recognition based on Google Clouds. Due to many elderly people not being able to type on a keyboard, we have designed a voice recognition function that can convert the person's voice into text in real time, as an aid for sending text messages. Google has an excellent speech recognition API, which we selected to use for this task. The API converts spoken words into text using Google's cloud-based service. So we designed a program which will record audio and send it to the speech API and return a Python string. We also designed a recording monitoring function. When the elderly press speak button, the program will monitor the voice input status. It will not start recording until voice detected. During microphone voice inputs, we first implement noise and echo cancellation. If a program detects that the voice stops for more than 2 seconds, it automatically stops recording and uploads the recording to Google for analysis. Whereupon Google returns a text string, which we display on the GUI.
The GUI on the Raspberry Pi consists of two interfaces. The first part is the login interface. When a user tries to send a message, he or she has to click up the Sign Up button, where a sign up window will pop up. Then he or she must create a username and a password to register. After that, a notification window will pop up to indicate that the account number has been successfully registered. Once the user has logged in, he or she will see a messaging interface. The user will enter messages through the bottom window and then click the Send button to send. All messages sent or received will appear in the windows located in the middle. The Clear button on the left can be used to erase messages entered. Before the user sending a message, he or she must choose the person to whom will receive the message. The name is used to index information stored in the Twilio, a call tracking service, to retrieve that person's phone number. The Call Me button located below can be used to request a call from the person selected. The Yes or No button can be used for a quick reply of Yes I do or No I don't. The Speak button is capable of transferring voice messages to texts. This easy-to-use product can provide elderly users great convenience with large fonts and colorful interfaces.
Let me introduce part 5, Panic Button. Considering the risk of elderly person falling, we set up this function for the system. The elderly person just hangs the panic button around his neck. When there is an accident, he can simply press the button and send an alarm message to the contacts pre-installed in the system. In order to increase the wireless control rate and stabilize the connection strength of the signal, we replaced the built-in Bluetooth module with a wireless Bluetooth remote control module. The core physical object that implement the function is shown in the figure. The connection between the module and the system is shown below. We use a Linux system command called download Raspberry Pi matching GUI, which can receive the data signal of the module and send it to Raspberry Pi through the trigger of the hardware. By calling the database of GUI, the system accesses the GPL interface and makes use of the ring function. When the elderly person presses the button, the module will detect the high signal step and automatically send the alarm information. Alert! The elderly person is in danger. Please check it out to the contacts in the basic information base.
Well, let's begin the physical demonstration. This is an easy-to-use graphical user interface for the elderly. I will demonstrate it by assuming a daily situation. So just assume an elderly person is using this interface and this mobile phone belongs to his son who works outside. The father wants to talk to his son, but doesn't know whether it will disturb his son's work. So he uses the quick reply feature, this one, to text to his son, asking him to call back. So first, select the contact his son and click this button, call me. And you can see that my phone received this message successfully. Are you busy now? I need your call me. In this demo, please ignore the preceding text because my Twilio account is a child account. So well, his son is in a meeting, so he texts back to his father. I'm in a meeting, can you text me? And his son sent a message. You can see that the Raspberry Pi received this message. Twilio sent back a confirmation message. But his father has difficulty typing on a keyboard. So instead, he can use voice recognition by pressing this button, speak. However, our Raspberry Pi's sound card and microphone could not be delivered on time before the university's lockdown. So instead, I use a laptop to demonstrate this function. Loading the interface, and the father pressed the button speak. Are you coming home for dinner tonight? You see that my speech was accurately transcribed by the Google Cloud service that we have connected to. We expect that this can be operated just as well on a Raspberry Pi computer because all the processing is done in the cloud. And we send this message. And you can see that this message was received successfully. Now I will use the Raspberry Pi to demonstrate the dead panic button. When the elderly person has an emergency, he can press this button anywhere within 30 meters of the message unit. This is our message unit, and this sends a signal to the Raspberry Pi, which immediately sends an emergency text message to a pre-installed number. Just like this, I press this button. And you can see that the elderly person is in danger. Please check it out. This concludes the demo of some of the functions in our design. Thanks for watching this video, and we are looking forward to hearing your comments.